more properties or laws of exponents that we need to look at. So let's look at the product rule. You know from regular math that product means multiplication. Product is the answer to a multiplication problem. So when we look at the product rule, that means if I multiply two exponential expressions with the same base, now that's key. These both have the same base of x. When I multiply two exponential expressions with the same bases, what I'm going to be doing is I'm going to add the exponents together. So x to the 5th times x to the 4th would be x to the 5 plus 4, which is x to the 9th. Why is that? Well, x to the 5th is the same thing as x 5 times, right? And then we're multiplying it by x to the 4th, which is x 4 times, correct? So altogether, how many x's do I have? I've got 9, okay? So let's look at some practical examples here. I've got 2m squared times 3m cubed. Well, whenever you have constants involved, you always just multiply the constants out. So 2 times 3 is 6. And then I've got the same base. I have m and m. So I've got m squared times m to the 3rd. Now remember, when you're multiplying and you've got the product of two exponential expressions with the same base, we add the exponents. So I'm going to add 2 plus 3, and I'm going to get 5. And I'm done. There's my answer. So let's look at this one. It's a little more complicated. Again, pick out your constants. So I've got 2 times 5, which is 10. And now let's look at the bases. I've got x as a base and x as a base. So let's add their exponents together. I have 3 plus -1. That gives me 2. I've got a y and a y. I've got -3 and +3. -3 plus 3 gives me 0. However, I don't need to write y to the 0, and we'll come back to that. There is another rule that we're going to examine down here, and we'll come back and we'll fix it, and I'll show you how we can change it. So let's go down to the quotient rule. The quotient rule is the same thing. Product is multiply, quotient is divide. So the quotient rule is what happens when we have two expressions with exponents that are in fraction form. They're rational. They're basically being divided. Because a quotient, remember, is the solution to a division problem. So, or a division operation. So here's the example. I have x to the 5th over x to the 3rd. Whereas in the product rule we added, in the quotient rule you're going to subtract the exponents. And here's why. Let's take this x to the 5th over x to the 3rd. If I were to write this out, that would basically be x 5 times on top over x 3 times on the bottom. And what cancels? 1, 2, 3. And how many x's are you left with? X squared. So that's where we get the subtraction. So let's look at this. Once again, the constants, you do the constant operation. So I've got 4 divided by 2. That gives me 2. And then I have r to the 7th over r to the 3rd. Again, it's subtraction because this is a quotient. So 7 minus 3 is 4. So this completely simplified would be 2r to the 4th. So let's look at number 2. This is a little bit more of a doozy. The constants are 2/3. We can't do anything about the 2/3. So the 2 stays on top, the 3 stays on the bottom. Let's see what we can do. I have x to the 4th over x squared. So I'm going to subtract 4 minus 2. So that gives me x squared. There's no longer an x in the denominator. I have y to the -2 over y to the -3. And here's where some people get confused. Y to the -2 divided by y to the -3. Well, remember, we subtract the exponents. What happens when I do -2 minus -3? What does minus a negative change to? Positive. So that actually gives me y to the 1st. If you want to write the 1, you can. But remember, anything to the 1st power, you don't have to write the 1. And then the next one is z to the -3rd over z to the fourth. So I've got negative 3 minus 4. And that's not a negative, so therefore it's just negative 3 minus 4, which is z to the negative 7th. Now, I would be satisfied with this as your answer, but we can actually get rid of that negative exponent. Since we have a negative 7, how do I make it a positive 7? I just switch it into the denominator. So I could actually write my answer as 2x squared y over 3z to the 7th. Because I'm going to take that z to the negative 7 and just move it into the denominator and change the exponent to a positive. And that's the quotient rule. Now remember I said we were going to come back up here to this particular expression. Well, now you'll see why. We're going to look at the zero rule. The zero rule is very simple with exponents. It basically means anytime you have a value raised to the 0 power, that value is always going to be 1. X to the 0 is 1. 25 to the 0 is 1. The entire quantity, negative 12 to the 0, is 1. So let's see if we can solve these. 8 to the 0, you guessed it, 1. 3 times x to the 0, well, be careful with this one. X to the 0 equals 1, but I still have a 3 out front, so I've got 3 times 1, which will give me 3. That's where you have to be careful, is when you have a coefficient or you have a value out front. The last one, negative 5 to the 0, look at the difference between this one and this one. Where do you see the negative sign in this one? It's on the inside of the parentheses. That means it is included in what we are raising to the 0 power. We are raising the entire quantity, negative 12, to the 0 power. Therefore, it is still 1. Here, order of operations, you do the exponent first. This is the opposite of whatever we get for 5 to the 0. So this one is actually going to be negative whatever we get here, which is 1. So it's negative 1. You have to be very careful on that one. Now let's go back up to the top. So now we re-examine this one. I've got 10x squared y to the 0. What do we know y to the 0 is going to equal? 1. So I actually can just write this answer as 10x squared because this is equal to 1. I don't need to write times 1. So that's the answer.